The bottles up, we're over the top, it's time to get wild. The time of our life, it's happening now. We're out of control, together we're rolling over and over. We down the river, we drunk, and all of our thumbs went up in the air. Sunken in the wind.
Ladies and gentlemen, may I have your attention, please?
There's another side that you don't know, you don't know.
Engineering materials refers to the group of materials that are used in the construction of man-made structures and components. It deals with fundamental properties and characteristics of materials to be used in construction industries. Generally, everything we use in our daily life may be customized to be used in specific situations. The same goes for the construction purpose. The material required in constructing any building or infrastructure need to be tailored to be satisfy the design requirement and client needs. If we know the properties of each material beforehand, we can do this efficiently. As a result, materials have been extensively tested for their properties and categorized into broad groups. From this classification, the general property of any set of materials can be determined. The major classifications of engineering materials include metals, ceramic, polymers, and composites. All the general characteristics of properties of the specific materials are determined under these four major groups. The properties of various engineering materials should always be studied in order to specify them for a specific use and be tested for suitability in a construction project. It is important so that the project meets the general needs of any construction project, including its safety, such as the strength and durability of the material, economic factors, such as cost and availability of product, and aesthetic. So in this project, we will be promoting on some construction material innovated by the participant of Malaysia Technology Expo 2021, organized by professional trade exhibition and meeting planners. There are three innovations of construction materials highlighted in this project, which are mortar, ceramic, and cement. Sometimes, construction projects do not always go as smoothly as planned due to some issues that may arise. One of the most common issues in construction projects is the material procurement. Having the right material at the right time can be challenging. In general, sometimes the manufacturer's supply is delayed, sometimes materials are only available from specific regions, and sometimes issues in customs the materials may arise. It is important for construction material suppliers to provide the correct material in the exact measure and kind and deliver them at the right time so that the project will run accordingly to schedule. Without the correct material arriving in the correct location at the correct time, the design project will not ever be constructed. Otherwise, it may be low in quality if the project is done. So, in order to solve the material procurement issues, many new construction materials are being innovated by the participants of this expo. Firstly, 2 out of 3 of our highlighted construction materials from this expo utilize the waste in construction materials production of construction industry. The produced material is fully processed from the basic waste material, so materials shortage issues can be overcome since it utilizes the waste which will not run out. Secondly, one of our chosen construction material is produced from raw materials that are fully obtained in Malaysia. Besides to help in lowering the cost, it is recommended to use local materials since importing materials from another country may cause issues regarding paying the custom fees, which leads to the construction project to be delayed. Lastly, all the innovative construction materials chosen from this expo also focus on the economic factors. They all are being produced with a lower energy consumption and using simple and economically methods. As the generation, conservation, and distribution of energy is one of the most intimidating challenges facing the world today, this innovation plays an important role in leading the world towards a bright future.
The first product that we choose is sandit. Sandit, which is the alternative sand in mortar for IBS. The consumption of natural sandpaper from the river was too high due to its excessive use in concrete. The demand for this natural sand were increasing from time to time, especially on developing countries, for instance like Malaysia. Thus, the construction industries are in stress to identify the alternative methods and materials to reduce the demand for natural sand. POFA, which stands for palm oil fluid ash, has been seen as one of the alternatives that can replace sand in concrete mixture production and therefore could reduce the excessive production of palm oil fluid ash. Our focus is on explaining how to create a sandit, which is it is an alternative sand for mortar that promotes a simple and novel manner to utilize as a pre-made packed sand in mortar. POFA is used as a partial sand replacement for the industrialized building system, which is IBS, as a sand substitute sand dips improve workability and compression strength significantly. The product is beneficial to construction industry players and has a positive socio-academic impact. The formulation of this product is the basic ingredient of the sand dip is POFA, which is palm oil fuel ash. It is then blended into a green material which is turned into a sand dip. Since POFA whose chemical composition contains a large amount of silica in form of oxide, it is suitable to act as sand replacement. The ash of POFA was then oven dried and passed through 90 micron sieve and used for sand replacement. The raw materials in producing mortar are water, cement, and the sand replacement which is sand dip. The silica, which is SiO2 content in palm oil fuel ash, is able to increase the compressive strength of concrete and able to reduce the water absorption. The data that we obtained from the study, POFA as a partial sand replacement with dosage level of 10% of zinc weight is able to increase the strength of the concrete more compared to control sample. It is due to CS with H gel in the POFA that generates bonding between aggregate and cement, which contributes to the increment of concrete strength. At the same time, the fine particle in POFA is beneficially used as a filler to fill the void in the concrete. Hence, it will increase the density of the concrete, which induces its strength. In contrast, liquid method with dosage level of 10% POFA contribute the highest effective strength to the concrete performance. It can be inferred that concrete containing POFA at various dosage levels and mixing methods would increase the strength of the concrete. The novelties and uniqueness of this product. To begin with, the devices promise to tackle the problem of trash dumping in landfills by repurposing the waste in the building industry's material manufacturing. Sand dip is ready to mix, which is individual household users can simply mix the product with water and cement according to the simple instructions provided and self-boot whatever structure that they wish. Firstly, it is 100% green waste, which is as an alternative to fine aggregate or sand as the primary component of the IBS system. Sand dip's rheological properties are similar to fine aggregate, and the abundant resources of POFA from the oil palm sector can help to save the environment and natural resources. The cost of IBS component, particularly the costly sand, can be decreased by using sand dip. Secondly, the use of sand dip as an infill material in an existing hollow core of IBS wall design improves the IBS wall performance. The use of sand dip as a fill material improves the existing of IBS wall compactness. This is the factor that improves the IBS wall's performance, particularly in terms of mechanical qualities. Sand is used in the current design of IBS component, which will raise the price of the IBS component. The additional cost of sand can be decreased, and the additional performance from the action of filler in the IBS structure can be attained by applying sand dip. Thirdly, when a load is applied to an IBS wall, the existing design can cause a crack and a surface fault, which can be remedied by employing a sand dip as a patching material. The use of sand dip in combination with an activator and cement will provide an excellent binding material for the calcium component in the POFA. This is the key features that make sand dip a viable alternative to sand and filler material, as well as a unique repair solution that is low cost due to the use of waste material. From these assertions, the use of sand dip, which is made from waste from the palm oil industry, can be a viable replacement to sand as a natural resource. Furthermore, the use of waste POFA in the production of sand dip aided the achievement of Sustainable Development Goal, which is SDG 9, which is Industry, Innovation and Infrastructure. Sand dip's novel product can raise awareness in the plantation and construction industries about the importance of waste management in providing a safer environment for humans and preserving natural resources that are irreplaceable and cannot be replaced.
There's another side that you don't know.
Ceramic tile have a variety of applications, making them ideal for long-lasting and user-friendly design with a variety of aesthetic options. They are commonly used in the construction industry, such as floor, wall tiles, and others. However, because traditional ceramic tiles are produced at high temperature of 1100 to 1200 degrees Celsius, a broad amount of carbon dioxide was emitted and a huge amount of energy was consumed during the manufacturing process. Moreover, approximately 0.2 kilograms carbon dioxide per kilogram or 3 kilogram carbon dioxide per meter square of ceramic will produce a large amount of greenhouse gases. For the second product of our group, we choose color tile. Color tile, which means low carbon tile, was innovated in Malaysian Technology Expo MTE 2021 as a brand new approach in fabricating an environmentally friendly tile that corresponded to the Sustainable Development Goals. This product for construction material was the creation of research project led by Associate Professor Dr. Hayacheyo and other researchers from GGOTech UNIMAP in collaboration with Ceramic Research Company. Color tile is intended to reduce carbon dioxide emission. Color tile is an environmentally friendly material created using geopolymers technology as a strategy to address the disadvantages of previous tile while satisfying the goal of Sustainable Development Goals (SDG). Color tile is a low carbon footprint tile with an energy-saving production that is formed by casting or pressing the mixture of aluminosilicate and alkaline silicate solution followed by room temperature curing. Furthermore, the source of solid aluminosilicate material could be industrial byproduct like slate and fly ash, making color tile even more sustainable and environmentally friendly. The invention satisfies SDG 12, which is responsible consumption and production, and SDG 13, which is climate action. This effort protect the environment, facilitate the transition to a low carbon society and economy, and improve the nation's lifestyle quality. Color tile is made by mixing solid aluminosilicate and an alkaline activator solution. It could be done by placing the slurry into a mold or by pressing the slurry. Color tile is an invention with a low carbon footprint. The trump card is not only the energy-saving construction method, but also versatility of raw material sources, as color tiles can be made from a variety of waste material, including fly ash, slate, and dry husk ash. The use of this material recycle industrial byproduct while also helping to solve landfill problem. Color tile's capability is broad as it has the potential to be used globally as flooring and wall tiles, cabinet tile for kitchen and bathroom, and outdoor pathway and walkway usage. Color tile's invention has a long-term huge effect on the environment, economy, and society, which benefit the entire world. For instance, color tile has a huge effect on the environment because it helps to preserve the environment and reduce global warming by investing in low carbon technology. Low energy and production costs can lead to the long-term economic growth, while low carbon dioxide gas emission from color tile processing can improve our quality of life. As a result, the SDG 12 and 13 could be met by using the environmentally friendly color tile. Overall, traditional ceramic tile processing consumes a lot of energy and emits a lot of CO2. As a result, color tile was specially designed using abundant resource available around us to conserve the natural environment and resource as it is sustainable with a low carbon footprint and energy saving, as well as to overcome the damage that we did to our mother nature, as it can reduce the carbon footprint from industry, which is in connection with SDG target. So, why are you holding out for? If you care about human rights and future, color tile is the tile for you.
Mortar is a composite material which consists of mixture of sand, a binder such as cement or lime, and water, then applied as a base which then sets hard. Ordinary Portland cement or PC has a significant role in mortar as a binder and is held to minimum consistent with desired strength and water tightness. Due to increasing its energy consumption and high carbon dioxide CO2 emissions from production, more thermal energy will trapped by the atmosphere and it will be causing the planet to become warmer than it would be naturally. So, alternative binding materials need to replace OPC partially to reduce the greenhouse effect due to the emission from the production. New alternative materials need to be found for sustainable development to substantially decrease the consumption of natural resources, become vital to shield interests of future generations. Eco-friendly ternary blended cement is another alternative for cement to find a solution to reduce the cement usage in mortar, and it was innovated by a participant of Malaysia Technology Expo 2021. Eco-friendly ternary blended cement are consist of dry husk ash and municipal solid waste incineration bottom ash. IHA and municipal solid waste incineration bottom ash are using to replace a specific quantity of cement. They use special cement replacement such as pozzolanic material can improve the durability of the mortar produced. The pozzolanic material may be defined by its ability to react with calcium hydroxide. Pozzolanic material should consist of siliceous or a combination of siliceous and aluminous material in a finely divided form that in the presence of moisture will react with calcium hydroxide at ordinary temperatures to form compounds possessing cement properties. The chemical reaction occurs in the Portland cement when pozzolans are added and react with water is called a pozzolanic reaction. In this reaction, a silica, its precursors with the absence of cementing properties, converts into a calcium silicate with good cementing properties. In chemical terms, the pozzolanic reaction occurs when calcium hydroxide, also is known as Portland. It reacts with silicic acid to formate calcium silicate hydrate. The pozzolanic reaction is a long-term reaction that includes silicic acid, water, and CaO. This may be irreversible. The high amount of free calcium in pH 12 or above must be needed to initiate the pozzolanic reaction. Rice husk is an abundantly available waste material in all rice-producing countries, and it contains about 30% to 50% of organic carbon. Grinding RHA into cement enhances the qualities of concrete by reducing porosity, increasing resistance, and increasing strength. Bottom ash is the main solid residue which is produced by municipal solid waste incineration facilities. To be reused in public works, it has to be stored previously a few months. This material is composed primarily of a mineral matrix but also contains unburned organic matter. Bottom ash was used to determine the feasibility of the substitution as recycling product from industry depending on the percentage of characteristic of Portland cement mortar and provide beneficial mechanical performance. Municipal solid waste incineration bottom ash and RHA are waste utilizing to replace some of the cement in mortar to reduce and stabilize the demand for the construction industry. So, it benefits in reducing carbon dioxide emissions into the atmosphere, reducing waste footprint, and having a positive impact on the environment. The formulation of this innovation is cement, RHA, municipal solid waste incineration bottom ash, and sand will be mixed up together. After that, add the water into them, becoming mortar mixture, then sets hard. This innovation can develop new products that can be used in the construction industry as cement substitution materials in concrete. It also can reduce the waste by recycling to make a new product that can be used in the construction industry and reduce disposal space in the landfill. Sustainable resources using waste to produce new alternative products. For 50 kg of cement used can save up to RM2. The waste material can be found easily in Malaysia, which can get it for free. As a conclusion, eco-friendly thinner blended cement is the new alternative for cement to reduce the cement usage in mortar. Both raw materials that consist in this innovation are waste materials that are obtained abundantly in Malaysia. It can be described as an innovative inventory using simple and economical methods in concrete mix innovation. This product can replace up to 50% of cement as binding materials in construction materials.
So, for the conclusion from this expo, we can conclude that all the construction materials innovated by the participants can bring many advantages to the construction industries in the future. Materials engineering is concerned with the creation of new materials as well as the improvement of the current ones. This includes making things more durable, lighter, and practical, as well as more sustainable and cost-effective. By that, the study on engineering materials should be done continuously from time to time along with the development of new technologies. Every country should encourage the innovators and inventors to share and inculcate novelty and sustainability in their research, including the construction industry. It is not just about making new and better products. It encompasses all aspects of ideas, processes, systems, services, methods, and models of the materials innovated for the construction purposes. By that, every country around the world can exchange their research with one another and together can lead the world toward better development into a better future, especially in construction industries.
My boys won't hesitate to run up on your boy. 엉덩이 빵빵빵 남자들은 탐탐탐 내 입술 냠냠냠 어딜 가도 당당당 등장은 짠짠짠 뛰자 뛰자